This is part 2 of the init pen problem. We'll begin with part E. Here we're trying to figure out what the expected revenue would be if they ensured that every full-price customer would receive a room. We know that the revenue for full-price customers is 200. We expect that demand of those customers is 70. There'll be 70 rooms filled. Plus, the remaining capacity, or 150 minus 70, or 80 rooms, times the lower price point of the leisure customers of 120. And we get, therefore, that there's a revenue of $23,600. For part F, if we didn't predict any rooms, then we would assume that, and charge everyone the leisure traveler price, we'd assume that all 150 rooms were sold at this price of 120 for a revenue of just $18,000. Finally, for part G, if we protect 50 rooms, to determine the expected revenue, we'll first have to determine the number of expected lost sales. So we'll do this by calculating a z-value of 50 minus 70 all over 29. That corresponds to a z of negative 0.69. If we look this value up in a standard normal loss table, we get an L of z that's equal to 0.8353. So now our expected lost sales are equal to our standard deviation of 29 times this L of z of 0.8353, and we get expected lost sales of 24.22. Now, if we know that our expected sales, given that we have a mean forecast of 70 less these lost sales, is equal to 45.78. Applying these now to our revenue, what we know is that we protected 50 rooms at the high price, so the other 100 will sell for $120 per night, plus what we expect to sell of high-priced customers, which is our expected sales, times the 200 price point. And we get expected revenue, therefore, of $21,155.